All right, what we talked about today was one-step equations, two-step equations, and then implementing the beginning stages of geometry in proofs. So we talked about what given meant, and we talked about what prove meant. So you can automatically sub in the 3 in for x right here, because 3 is x, and then do plus 2, and you can check that it's right. 3 plus 2 is 5. Got it. No big deal. But one thing we have to do is prove the steps. So our given was x plus 2 equals 5. What was the reason for us having that? It was given. I just don't want you to be seeing this for the first time when you're in class. And then we would go through the steps of solving a one-step equation because there's only one operation in it. Doing the inverse, minus 2, minus 2, and positive 2. Minus 2 is 0. X equals 3. And that checks out with everything that it said to prove. Cool, we got the same answer. Now, the way that we got that answer was looking at the minus 2 on both sides, and that we did it to both sides. So that number 2 is going to be the subtraction property of equality. These are the same problems I gave you, or should be at least, on the page of work to go ahead and go through it on your own and then go, okay, where did I mess up? Where did I make mistakes? And do some corrections. Then we're going to keep on doing this. We're going to keep on cycling it through, and then we're eventually going to get to a geometric figure and using these things. The given, it states, is 2x plus 3 equals 9. And I like that whenever we were going over it, you said, like, hey, I'm just going to solve this and then see what we can do from there. So I'm going to go ahead and do that, and then I'm going to make sure that the left side links up with the right side as why we're providing that reason for what we did. So we know we're solving PEMDAS in reverse, so we're going to start with addition and subtraction. Okay, we know that that goes away because it's 0. We're going to drop down to 2x. And 9 minus 3 is 6. This is going to be our second step. So once we've done the work and then we have a new problem to solve, that is the next step. And we have to give a reason as to how we got there. So let's do the next step since we had a two-step equation. We know that a number next to a letter means multiply, so we're going to divide on both sides. And the reason I'm saying both sides is because that's part of the property of equality. Whatever happens to one side has to happen to the other to make it stay equal. 2 divided by 2 is 1, and you can put a 1 in front of the x, not a big deal. And then 6 divided by 2 is 3. So you can see that the answer that we got for number 3 is exactly what it said to prove, x equals 3. So we don't have to check it because we got the answer that it said we were supposed to get. Now, what was the reason? Well, the reason we started off with the problem is because it was given. And don't think of given as some like obscure word. It means that that's what they gave you to start proving it. The second step, the way that we got there was we did minus 3 to both sides. So we did subtracting property of equality. And you may not run into these definitions, but if you are asked to prove an equation, these would be the properties you would be using. And I just want you to understand that there's going to be vocabulary associated with the reasons for the math that you're doing. So how do we go from step 2 to step 3? Okay. This is where the third reason comes in. Well, it looks like we divided by 2. So we have the division property of equality. That is a algebraic proof. So this is your introduction into solving proofs for geometry. Very similar problem. I'm going to start with the given. 2x plus 1 equals 3. And I'm going to go ahead and start off with the reason too. So every step I do, I'm going to go ahead and do the reason. We're going to start with addition subtraction, doing its inverse. We talked about inverse meaning the way that is the opposite or the way to undo it. The example we used was an open door. What's the inverse? Is a closed door. 3 minus 1 is 2. Okay, so the way that we got to step 2 was by subtracting 1 on both sides. So step 2, we got there by the subtracting property of equality. How are we going to get to step 3? Let's see. We know that a number next to a letter means multiply, so we're going to divide by 2 on both sides. And the reason that we're doing it on both sides is because of the property. So really, you've been using mathematical rules without knowing the definition, which isn't a problem until now. So now we need to start knowing why we're doing it. 2 divided by 2 is 1. I'm just going to put a single x there. 2 divided by 2 is 1. You can see that step 3 is exactly what it said to prove. That means our answer is correct. So how did we go from step 2 to step 3? We divided by 2. So we can do divide property of equality. So this one looks a little bit different. It's got division in it. I'm going to start with writing down the problem and then going over to the reason as to how I got that. First step is because it was given. Now, what would I do next? And we know that we're doing order of operations in reverse since we're solving for a variable. So minus 3 would start addition and subtraction first. Minus 3's inverse, plus 3. And that would go to 0. I'm going to drop down that x divided by 3. This would be our step 2. Equals 1 plus 3 is 4. So how did I get my second step? Well, if you look at this, we did the inverse of minus 3 to both sides, which is going to be the addition property or additive. I'm just going to put adding property of equality. Now what will we do next? Well, I know that I'm looking at the side with the variable. So the variable is x, it's on the left, so I know that I'm going to be looking at a fraction. Fractions always mean division. So that means I'm going to be doing its inverse to both sides. I'm going to be using that property of equality. So x divided by 3 times 3, so that's 1/3 plus 1/3 plus 1/3 x will give you 1x equals 4 times 3 is 12. Now how do we get to the third step? What's your reason? Well, you can see in the blue, the thing that we did to both sides was the inverse of what's happening in the problem. And that was multiplying by 3. So we can say the multiplicative, or just the mult prop of equality. You could say multiplying property of equality, as long as you're conveying the reason as to how you know to get from where you're going. Oh man, look at this. How did that happen? X equals 4. Well, let's see. Did we prove that x is actually 12, or is this problem wrong? Let's find out. So this is where I was telling you to check answers. If something doesn't line up, you know that something's wrong. So I'm going to use a different color. I'm going to use orange. Go over here. So let's say that x is 4, okay? This is why we went through checking, because you're going to see which one is wrong. So 4 divided by 3 is 1 1/3. So let's do 1 1/3 minus 3 equals 1. We automatically know that 1 1/3 minus 3 is not going to be 1. So we know that this x equals 4 is incorrect. Let's check the 12, because I feel like we did all this work right. So is it that the problem is wrong? Now you're sitting there going, oh, that's why we do proofs. So 12 divided by 3 minus 3 equals 1. So doing order of operations, since we don't have a variable, no parentheses, no exponents, but there is multiplication or division, 12 divided by 3 is 4 minus 3 equals 1. Hey, we were right. X does equal 12. And not only did we show algebraically how we got that answer, but we also checked it and we provided the reasoning behind it using mathematical definitions. Okay, same routine. 1 plus x divided by 4 equals 4. That was our given. You know, sometimes you'll be given like a quadrilateral, and it's going to ask you to prove how, angle x is 90 degrees. And then you're going to have to go through the definition of a quadrilateral and how you know, by definition, that one angle is 90 degrees. So this is just practicing going through the motions of reasoning of what you're doing. So you can see that we're adding a 1 here because we're going to do addition and subtraction first because of order of operations in reverse. So minus 1, minus 1. That'll go away. We're left with x divided by 4 equals 4. And that will be our step 2. So how did we get there? Well, it looks like in the blue we had minus 1 on both sides. So we got to step 2 by saying the subtraction property of equality. What you do to one side, you have to do to the other. And since we're solving a problem backwards, it's the inverse. All right. Next, a one-step equation, looking at the side with the variable, x divided by 4 equals 4. So doing its inverse to solve it in reverse, multiply by 4. Okay, and then that'll give us our step 3, which is x, because if you have 4 times 1/4 x, 1/4 plus 1/4 plus 1/4 plus 1/4, that'll give you a 1. So that means we have our 1x equals 4 times 4 is 16. Okay, interesting, because this answer does not match with this. So let's see which is right. But first, let's go to the step 3 and see if we can. What do we do on step 2 to get to step 3? Looks like we multiplied both sides by 4. We get it to both sides. So multiplicative property of equality. But, I mean, as you can see, it says prove that it's 12. Okay, well, it looks like we proved that it's 16. This is why we are able to check answers. This is why our reasoning is proving our answer is correct. So 1 plus, let's see what their chump answer is. 12 divided by 4 equals 4. All right, so let's see. 12 divided by 4 is 3. So 3 plus 1 equals 4. Huh, interesting. Did we make a mistake somewhere? Well, let's take a look. Let's substitute our answer into the original problem. And the only reason I'm doing this is to highlight why we check answers and why proofs are relevant. It's not to try and confuse you. All the steps that we did were correct, but we made a mistake somewhere. I'm going to show you where we made the mistake. 1 plus 16 divided by 4 equals 4. 16 divided by 4 is 4, and then 4 plus 1 does not equal 4. So that would tell us, hold up, I need to go back and look. And right here is where we made a mistake. Because 4 minus 1 is not 4, it's 3. So we should have had 3 times 4 right here. And then that should have been 12, and then we'd have matched up. So it's easy to make a mistake and still do all the proving of it and providing the reasons. But you still need to check it. Because, look, all this up here, this answer is correct. This answer is not. That tells you need to go back and check your work again. Next time, we're going to follow up with more vocabulary. The vocabulary that we used today was quadrilateral. Oh my goodness. That's not good. Quadrilateral, and we define that as any four-sided figure. And then the other one that we use today that we're emphasizing is rectangle. You told me that it had 4 sides, 2 pairs of congruent sides, 4 right angles, and if you wanted to go a step further, you could say that it has 2 pairs of parallel sides, which would look like this. So there's 1 pair of parallel sides. That's going to be notated with a little arrow saying that these are parallel. They will never touch. And then to close off the rectangle, you'd have 2 more symbols with arrows saying that these 2 sides are parallel and they will never touch. The symbols that we were using to say that they were congruent were dashes. And the symbols that we used to say that there were 4 right angles were little boxes in the corners. Just become well versed in knowing what a rectangle is. I thought you did a fantastic job today of knowing what a rectangle is, what a square was, what a rhombus was, and what a parallelogram was. The majority of the things you're going to be seeing are variations of parallelograms and a rhombus. But it pays to know the definitions of rectangles, squares, and other quadrilaterals so you can provide the evidence for proofs.